How we doing, guys? So today we're going to take a look at how to complete a mass-to-mass stoichiometry problem. Okay, so a couple things you're going to need. Okay, this right here, we're going from mass to mass. So we're going from box 1 to box 4. So you need your mole map. This is the one I give my guys, my students here. You'll need a periodic table. And that's pretty much it. Those are the two tools you need. So we're going to go over and walk through problem or two for you guys. All right. So how I go about this is you got to underline what you're given and then what you're looking for. So determine the mass of iron 3 hydroxide, which should precipitate when a solution containing 3 grams of iron 3 chloride reacts with an excess of sodium hydroxide. Well, what the heck is what? There's 3 different things. What, blah. All right, fair. You're going to underline, all right, obviously the dude that has a number with it, that is your given piece of information. All right, the excess sodium hydroxide, that's just basically saying, okay, they want to know if I start with 3 grams of iron 3 chloride, this guy here, and I have an unlimited supply of this, how many grams of this product over here can I make? That's what that is. All right, but anyway, in the problems, figure out what you're given, label that A, and underline what you need. They said determine the mass of, or what is the mass of, or calculate the mass of. So we're looking at mass of iron 3 hydroxide, and I label that as B. All right, because we're going from one substance to another. Now, I also like to, over the equation, write down who's A and who's B. A was iron 3 chloride, this guy here. So we'll put a little A above it. And substance B was going to be the iron 3 hydroxide, this guy over here. All right. If you're not sure sometimes, should be able to figure certain things out. You should know that by now, if you're in the stoichiometry, that's sodium chloride, that's sodium something else, neither of which were asked. So you have iron chloride and iron hydroxide. Well, you should also, again, know what chlorine is, chloride, and you have your hydroxide. Okay. Now, good. We got this. We want to go from grams of substance A, so we're starting in box 1, and we want to get the mass of substance B, which is here. So we're going from box 1 to 4. So what I have highlighted here in yellow are what we're going to use. Those are the conversions that need to be used. Okay. So always take what you're given and put it in your what I call the starting spot. So you're going to write it. I don't need to write the 3.00, but so it's 3 grams of FeCl3. Okay. Here's a little conversion line. Boom. This goes over nothing. We don't need to worry about it. First thing it says 1 mole of substance A. What was substance A again? Oh, good thing I wrote it above. So you're always going to have 1 mole here. Also to note that this equation is already balanced. Okay, it's a 1 to 3 to 1 to 3 ratio. If there is no coefficient written in front of, it's to be understood that it's a 1. Okay. So we got 1 mole of A. Substance A was iron 3 chloride, so we have our FeCl3. Underneath it says the molar mass of substance A. I don't know that off the top of my head, so I leave space on the left-hand side for this reason. You write it out, FeCl3. Okay, how I do the molar mass, try and do it as quick as possible. First element, throw up a parenthesis. Get your periodic table out. Where did I put mine? Over here. All right, we look for Fe. Bam. 55.85. Grams. Okay, are there any other Fe's? No, there's no subscripts here, so that doesn't matter. A question I got asked today, side note, if we were doing, let's say, NaOH, and we were finding that, do I multiply that whole thing by 3? No. The coefficients only get used here when converting over from moles of one substance to moles of another. Otherwise, the molar mass do not care about the coefficients. Subscripts, yes. Coefficients, no. Okay, so first element, once you find its mass and however many there are, boom, good. If there's another element, throw a plus sign. So the next element is chlorine. I know that one off the top of my head is 35.45. And how many chlorines do we have? 3. This 3 only applies to the chloride, so we got to do this. Are there anything else? No, so there's no more plus signs. You got to just equal that out. Okay, so you're going to plug that into your calculator. You're going to kick out an answer of 162.2 grams. That's grams per mole. So in 1 mole of that, we get 162.2 grams. Okay, conversion 1, boom, done. Conversion 2, it says the number of moles of B, number of moles of A. So blank, I'll leave a blank, I always do. Blank moles of substance B. What was substance B? Iron hydroxide, iron 3 hydroxide. So blank, moles of FeOH3. And moles of substance A on bottom, which was moles of FeCl3. Okay, where do these numbers come from? The coefficients from the balance equation. Remember, I wrote the ones in. You sometimes they may not be written in. Okay, it depends on how you're taught, but I just put them in for simplicity here. If there is no coefficient written, okay, and the equation was already balanced, then it's understood to be a 1. So iron 3 chloride is a 1. Iron 3 hydroxide is a 1. Boom. That gets us here done with, all right, our second conversion. Now, to go from 3 to 4, we have to have this as our last conversion. So it says 1 mole of substance B on bottom. B was the FeOH3, so we have 1 mole of that on bottom. And on top of it wants the molar mass of substance B. So again, I left space over here for that reason. Okay, iron, we already looked it up from the guy above, so it's 55.85. Are there multiple irons? No, so we close my parenthesis. Is there another element? Yes, add a plus sign. First element we see is oxygen, which is, you look on the periodic table, 16 grams. Okay, and how many? Well, in here, I only see 1, but when you have a subscript on the outside of parentheses for a polyatomic ion, it distributes inside. So even though there's only 1 oxygen, it's 3 times that 1. So we have to multiply this 16 by 3. And then, is there another element? Yes, it's hydrogen. We're calling it 1.01. And the same thing. There's 1 inside, but we have to distribute. So we're going to multiply this guy by 3 as well. That's it. Nobody else. So we got to equal this out, throw it into the calculator, and you should crank out an answer of 106.88 grams iron 3 hydroxide. That is our molar mass for substance B. So that is going to go over here. I'm going to write that. 106.88 grams Okay. Now we got to make sure all the units cancel out. We have grams FeCl3 on top and on bottom. Good, they cancel out. Moles of FeCl3 on top and bottom. Good, they cancel out. Moles of iron 3 hydroxide on top and bottom. They cancel out. The unit we're left in is grams of iron 3 hydroxide, which is what we wanted in the first place. You can cross out the unit, but not the actual numbers. And then what do I do from here, you ask? You take everything and multiply it. All right, multiply everything that's on top in this little setup. 3 times 1 times 1. Well, you don't need to do the ones, but 3 times 1 times 1 times 106.88 equals, and then divide by 162.2. Divide by 1. Again, since it's a 1, you don't need to. But if it was like a 2, it would be divide by 162.2. Then divide by 2 again. And so we throw that into the calculator, and you're going to get an answer of It comes out to be like 1.9768, I believe, grams of FeOH3. Now, you can round this depending upon whatever, sig figs or what not. I used, for my guys, if they wrote it as 1.97, it's fine. 1.977, fine. If they wrote this, fine. If they wrote 1.98, also fine. Okay. Don't forget, when doing molar mass, coefficients do not matter. Subscripts do. Subscripts do. Okay. So I'm going to then just throw up some worked out other examples so you can kind of see it, and we'll just kind of roll through it really quickly. All right, we had magnesium oxide. Calculate the mass of that if you were given 0.52 grams of magnesium. So I underlined that. That was my A. I wanted this guy over here. That was B. All right, we can write it as, okay, this dude is A. This guy is B. And go about it. So take what you're starting, take what you're given, put it in the starting spot. Okay, then according to this dude, 1 to 4. 1 mole of the substance A, which is Mg, underneath its molar mass. When it's an element by itself, super awesome. It's just whatever its mass is, atomic mass in the periodic table. Boom, write that down. Next step, moles of what we want on top, moles of what we were given on bottom, and the numbers here come from the coefficients of the balance equation, which was a 2 here and a 2 here. And then molar mass of the new substance, substance B on top, and 1 mole on bottom. Okay, MgO here. There were no subscripts, so you're just taking the mass of the 2 individual elements, adding them together, and multiply across. Mass of hydrogen gas, 3 grams of sodium. We have our A and B. Take what you're given, put it in the starting spot. Again, following the chart. 1 mole on top, molar mass on the bottom, mole ratio, molar mass of the new guy on top, and 1 mole on bottom, multiply on top, divide by on bottom, get an answer. Mass, barium sulfate, what is that? That's what we're looking for. What are we given? 12 grams of barium chloride. But it reacts with an excess sodium sulfate. That doesn't mean anything right now. That's basically just saying we are going to have plenty of this left over. But we only have 12 grams of this. So how much of this can we make? If we have only 12 grams of this and pretty much, let's just say, infinite amount of the other guy. Well, let's figure it out. Based off of the equation and their molar masses, take what you're given, put it in the starting spot. 1 mole of A over its molar mass. You had to calculate that over here. Barium, 137.33, plus chlorine, 35.45, but there's a subscript 2, so you have to double that. Get it. Boom, 208. Mole ratio. All right, it's a 1 and a 1 in front of these guys. Molar mass of the new substance. We calculated it out. Okay, now since, even though it's a polyatomic, the SO4 here, since there is no parentheses like there was up here, okay, nothing gets distributed. So it's only barium plus sulfate, then it's plus oxygen, whatever that was, times 4. You get your mass here. Okay, grams of barium chloride cancel, and moles of barium chloride cancel, moles of barium sulfate cancel. We're left in the unit we wanted. Boom, got it. Heck yeah. Let's see. Some people were unsure about this guy here. It says potassium metal reacts with hydrochloric acid to produce an aqueous potassium chloride and hydrogen gas. They're like, what the? I had some kids read it, and they're like, there's so much stuff, I don't know what the heck. Relax. Again, identify what you were given and what they are looking for. That will be A and B. Okay, then we get to use our map. Take what you're given, put it in the starting spot. Okay, I said that A was our H2, B was our potassium. 1 mole of H2 over the molar mass. Now, want to make sure that we don't mess this up. Because there's a subscript 2 here, a lot of times if people think, oh, it's just hydrogen, right, they just read hydrogen. Well, look how it's written in the problem. H is one of the diatomic molecules, part of Hofbrinkel. So H, you have to use that subscript of 2 there. So 1.01 times 2 to get the molar mass of the hydrogen guy. But potassium, there is no subscript 2, so you're just going to write what its atomic mass is. And I had kids ask me, hey, well, don't I multiply it by 2 because of that? No. Coefficient only comes into play in this middle section. That was it. Okay, so we had, boom, we get out of grams. Then we have moles of hydrogen. They have to be on bottom here. These two numbers come from coefficients of the balance equation. Potassium, which we want to get into, was a 2. Hydrogen was a 1. 1 mole of K on top, or the 2 moles. And then we have our 1 mole of B on bottom and the molar mass. Multiply everybody on top, divide by on bottom. Boom, get your answer. Okay, so guys, that's how you go about finding these type of problems. All right, another wrinkle could just be that you're given a problem where you have to balance an equation first. That is a possibility. So I'm going to show an example of, let's say, that. Again, you can't really do stoichiometry unless you have a balanced equation. Okay, so if I'm looking at this, I have nitrogen, I have 2 of them. I have hydrogen, I have 2 of them. On the other side, nitrogen, I have 1. Hydrogen, I have 3. Not really going to quite work, but hydrogen and hydrogen here, the 2 and 3, the closest thing they're going to share is a 6. So, whoop, I don't want to do that. They got to multiply it by what to get 6? If I multiply this by 3, it gives me 6. If I multiply this dude over here by 2, that will give me 6. So the 2 goes in front as my coefficient, but that also applies to this n now. So times 2 will give me 2, and we have 2 hydrogen, 2 nitrogen on this side, 6 and 6. So we're looking at a 1:3:2 ratio. Grams of nitrogen, 56 grams of nitrogen. That is A. That's what we're given. And are used up by the reaction, how many grams of ammonia will be produced? Grams of ammonia. Well, I'm not sure. What is ammonia? Well, guys, you should be, again, at this point where you recognize most elements. You should know that that's hydrogen, that's nitrogen. So ammonia will be the only one left here, which is the NH3. So if we're going from here to here, take what you're given, put it in the starting spot. So we have our 56.0 grams of nitrogen, N2. 1 mole of A, substance A on top. So that would be 1 mole of N2, which we were given. The molar mass of it on bottom. You can't just write its molar, you can't write the atomic mass there because it's N sub 2. So we look it up on the periodic table, I get a 14.01. And because of the subscripts, we have to double that. So you're 28.02. Next step, mole ratio. Blank moles of B on top. B, we said, was how many grams of ammonia? So that's B. NH3. So that is going to go on top. Moles of A got to go on bottom. That way it cancels out over here. Units come from, all right, these numbers come from our coefficients of the balance equation. NH3 has a coefficient of 2. Nitrogen has a coefficient of 1. Good. Now, last step. 1 mole of B on bottom. Substance B was ammonia, so we have 1 mole of NH3 on bottom. Sorry, didn't write mole. And then molar mass on top. I don't know off the top of my head, so write it out on the side. NH3. First dude is nitrogen, 14.01. Next element is hydrogen, which is 1.01, and there's 3 of them. Okay, this is going to count out 17.04 grams. That is the molar mass of ammonia. Okay, grams of nitrogen cancel, moles of nitrogen cancel, moles of ammonia cancel. And now let's throw this into our calculator. So you're going to do 56 times, we don't need to do times 1, times 2, times 17.04 equals, divide by what's on bottom, which is 28.02, divide by, nope, they're 1, so we don't need to, so this will be our final answer, 68.1113, yada, yada. So I'm just going to call it 68.11. Unit will be grams of NH3, or grams of ammonia. Ammonia, sorry. All right, guys. Hope that helped.